The first part is a straightforward question. Define delta H lattice.
The enthalpy change when one mole of ionic compound is formed from its gaseous ions under standard conditions.
Some data related to radium and sulfur are listed. Select relevant data from this list for use in your answers to part B to E. Write an equation for the process corresponding to the second electron affinity of sulfur. First electron affinity of sulfur and second electron affinity of sulfur. So should I make sulfur -2?
No, it's yes. The product will be -2. So it will be at minus.
It will be sulfur -1.
Yes.
And it has to gain an electron.
Yes. And it will form S2 minus.
Sulfur exists as acid molecules. Use the data in this question to calculate the enthalpy change for the reaction S8 sulfur to 8S. Apparently, this reaction should be matching with any of the reactions above, but do you think it's matching with this balancing?
No. No.
Do you think it's type of atomization?
Yes.
Good. So, how can I do it now? I know now this is atomization. Electron affinities are given. Enthalpy change of second electron, then lattice enthalpy of radium sulfide.
So
now,
can
atomization here. One thing is there, this is atomization. So, but we need to use data from this screen.
yes.
He says enthalpy change for the reaction S8 solid to 8S. So either I break the lattice or because I need sulfur first. First I need sulfur, then I need atomization, and then we have to use any one of them. We can make a triangle. We can make a triangle to make a loop here because we need two equations at least. I think we should focus on this reaction because it is giving me S2 minus.
Yes.
And I should be focusing on sulfur 2, sulfur minus 1. I mean this reaction. I need a reaction which starts or ends at sulfur because I have sulfur here. And you can see S8 is here. And here I'm having sulfur in atomic form. So if I think of a triangle, I can think that I atomize sulfur. I got 8 sulfur atoms, and then I break them into atomization. Second electron affinity of sulfur is also given. So let me see S minus 1 to give me S minus 2. Do you think that this also fit in my triangle?
Yes.
Very good. So I have 3 equations in line with me.
Mm.
Now think of a chain. I help you to start with the chain. I have S8, which breaks into 8S. You need to make a rough diagram for you so you can make a cycle. Sulfur 8 atomizes to 8S. This is the reaction for which I need to find the H. If I now make a loop and I make sulfur to S minus, okay, sulfur minus 1 further ionized to give me S minus 2. Now look at this position. Can I have S8 converting to S2 minus?
Yeah.
So now look at this arrow. Let me change the color. Now S8 is converting to S minus 2.
Yeah.
Now, how I made this triangle, I have collected all the possible things. The main idea to remember, you need starting and ending elements same. So what I noticed, look at here, I am ending at S minus 2, and this is also ending at S minus. Okay, now triangle is ready. Let me say it is H1, it is H2, it is H3. So can you make a head to tail working for me?
Okay.
The arrows in lines. So should I say H plus H1 plus H2 is equal to H3? Why equal to H3?
Because H3 is the total enthalpy change
Yes.
for,
Plus,
yeah.
as a rule of our logic, it is the overall root. H3 is root number 1, maybe, and H2 is root number 2. Root
Yeah.
1, sum of root 1 is equal to sum of root 2, right? Now,
Yes.
what should I do? I have made the triangle, I have made the equation.
We will substitute the values.
Okay.
So we will have H plus, H minus 200.
I have to find H plus H1. 8S2, S2S minus 1. S2S minus 1 is minus 200. Plus
Plus 532.
hmm,
Plus 532.
right,
Equal to 555.
right.
I'm getting the answer to be 223.
So when we studied this topic, we studied three important things: Hess's law application, making a triangle, because the energy level diagram is always take too much time. So triangle is always simple. Second thing, make an equation either on the logic of Hess's law, √1 is equal to √2, or on the logic of physics, arrows in the same direction are added, arrow in the opposite directions are added separately and equate. Now the third thing, which is very critical, check the balancing. If the balancing need, you have to multiply the energies.
Yes.
So can you now check any multiplication needed? I made a question mark here. S8 converted to 8S. Okay, and I put the double question mark here. Now this is a critical point to understand, that the root coming from single question mark side is getting 8 sulfur. Okay, but the double question mark is getting half. You can see this equation, 1/8 S8. I read that, I copy this equation here for more understanding. Look at this equation. 1/8 S8 plus 2 electrons gives you S2 minus. Now here is a problem. It is 1/8, right? And the equation we are searching is 8S. So we need a balancing. And we have to multiply our answer by 8.
Yeah. Okay.
Why we need to multiply our answer by 8?
Because we're getting 8S, but yes, for the first equation, it was 1/8.
Okay. Now logically, if I use my logic common sense, if I am getting 8 S atoms, will it be 8 atoms here?
Yeah.
And it will be 8 atoms here.
Yes.
So that makes sense. Otherwise, I can't balance it. But as he has put 1/8 here, I need to balance my answer. So 223 into 8. Now we have to do this calculation.
It's 1784.
Okay, if you want to copy anything from the screen, you can.
Okay, thank you.
The main thing is triangle.
Yeah.
Calculate the standard enthalpy change of formation of radium sulfide
Okay, I've copied.
good. Calculate the standard enthalpy change of formation. There are two possible ways always as a memory that in AS we have studied that formation is coming always from elements. Is it right? Formation is the
Yes.
enthalpy change that always arises from
Elements.
elements. But now here I am bound to use this table.
Can we use the lattice energy of radium sulfide?
First, we should see either we break the lattice, we have lattice enthalpy, right? And
Yes.
we don't have any other formation. So either we enthalpy change. Acha, we have the first equation is the ionization. First equation is the ionization of, because I think as a logic of doing CIE papers, we need to think something different as from the previous part. Let me rub it because we have to select equation. We have to make an equation. We have to make a word triangle. I have rubbed it. Now I need an equation first for my title. Standard enthalpy change of formation of radium sulfide. Radium sulfide means Ra. So can you help me writing the equation? I should Ra. If I write my title equation, Ra.
Ra gaseous to plus.
Yes, no.
Oh,
Enthalpy
the
change
formation.
of formation is making something from the elements in their standard state.
Yeah, okay.
So radium by nature is a solid.
Yeah. Plus sulfur, solid.
Okay. Radium solid plus
Sulfur.
solid.
Yes, it will give RAS, which is also a solid.
So I have made the title equation.
Yes.
This is how you always have to think. Now you have to make a link for all the possible equations which can help here.
Okay. We have the lattice energy of radium sulfide.
We have lattice enthalpy of radium sulfide, right? So that is looking to be right for me. So if I break this lattice, I will get Ra plus and S minus. If I make this lattice Ra plus plus S minus Ra plus 2, S minus 2, give me RAS.
Yes.
Now come to this equation. Can you see RAS here?
Yes.
And can you see RAS here?
Yeah.
So one end is matching. Now look on the other side, Ra plus and S minus 2. Ra plus is coming here. Look, Ra plus is coming here.
Yeah.
And S minus 2. S minus 2 is coming. So I take this equation also.
Yes.
Now, The third equation is a challenge now because two equations, I have selected two equations. I have to consider the third equation. When we make formation, we always have to take all the elements in their standard state. Now the question comes, am I taking S or am I taking S8?
S. Shouldn't we take S because we're getting 1 mole of radium sulfide?
No. Don't confuse with S8 with 8 moles. Remember, do you remember these? What is this S8? Do you remember allotropical forms?
It's 8 atoms of sulfur.
This is S8 is an allotrope of sulfur. It is a natural substance. It is not S8 somehow that we have joined them. S8 is a molecule, just like oxygen is O2, ozone is O3, sulfur in majority cases is S8. Sulfur is not naturally S.
Yeah, okay.
Okay,
But
how I get it? We get this point.
yes, I got it.
Good. So it means it is S8.
Okay.
Once it is decided that I have to take S8, my third equation will be this. So I have selected 3 equations.
Yes.
Now you have 3 equations from the table. And 1 equation is my unknown equation here. So how many total equations?
4.
So let's start trying to make a triangle or connected figure. If I make it RA plus S8, give me RAS.
Won't we have to balance the RAS?
You have to balance it definitely.
Yeah, okay. So it will be 8 moles of RAS.
Now you have to help me making this because I have a common connection. This is RAS and this is also RAS.
Yes.
So if I ionize sulfur here and I get S minus 2. And if I atomize Ra, if I add them, I will get this equation.
Yes.
So the diagram is ready. Let's say it's H, H1, H2, H3. How should I make the equation? H is equal to
Is
H1 plus
H1, H2. When will we balance the RAS?
Hmm?
For the balancing, when will we balance?
How we can balance it later, but did you understand the equation?
Yes, I understood it. But shouldn't it be H1 plus H2 is equal to H3?
It can't be. No? Look at the arrows. Arrows in the same direction. Again, they make the roots. Whenever you get a confusion, look, this is root number 1 ending at radium sulfide. Okay.
Yes.
This is root number 2 ending at radium sulfide.
Oh, okay. Okay, I got it.
Second approach is the arrow heading. Arrows in the same line are added. In physics, we have an interesting concept. If we make like this, A, B, we say it is A plus B. Arrows in a terrain are always added.
Okay.
Can you put the values?
Yes. It will be 1619 plus 555 plus minus 2612. It's giving minus 438.
Now check the balancing position. RA does not need any balancing. It's going the same. RA 1, 1 RA, 1 A, 1 RA, 1 RA.
Yes. For the sulfur,
Again, look at the equation. This equation, if you look at this double arrow position equation, is 1 upon 8 S8.
so we have to multiply by 8.
That is the question. I show you here. Let me try to adjust here if you understand this point. It's actually with the equation I'm taking is 1 upon 8 S8. So I put a plus here and I put 1 upon 8 S8.
Yeah, so it will be only 1.
Yes. So do you think now the equation is balanced?
Yes.
So we do not need any multiplication.
Okay.
Why?
Because we have the 1 mole of sulfur and 1 mole of
Because
radium.
the
So
555, because the 555 is coming from 1 upon 8 S8.
yes.
And the same 1 upon 8 S8 is balancing my both the roots.
Yeah.
So 438 is the answer.
Okay, I got it.
State two major factors that affect the numerical magnitude of a lattice energy. lattice enthalpy is directly proportional to the product of the charges and inversely proportional to the sum of the separation.
Yes.
So what are the two factors? Amount of charges and ionic separation.
Yes.
For each factor you have identified in E part 1, state whether it tends to make the lattice energy of radium sulfide more or less exothermic than of sodium chloride.
It will be more exothermic.
We have to see carefully. Radium is +2, sulfur is -2.
Yes.
Radium is +2, sulfur is -2. Na +1, Cl -1. The upper position goes in favor of radium sulfide. What about ionic separation? Can we judge that?
Yeah, because the radium has a large.
Numerator favors radium sulfide to be more energetic, more exothermic.
Yes.
But how we can check ionic separation? Can you look in the periodic table? Chlorine minus and sulfur -2. And you know that in a period left to right, atomic ionic radius changes. Down the group increases.
Yes.
So now we need who is a bigger or smaller.
Sodium chloride is smaller.
Chloride is smaller. Sodium and rhodium. Do you think radium is smaller than sodium?
No, radium is larger than sodium, but the chlorine, yeah, Ra+2 is bigger than sodium.
Okay.
And for sulfur, 1 second. Sulfur will be smaller than chlorine.
I feel it is a subtle effect because they are not the numerator is favoring sulfur, sodium, radium sulfide.
Yes.
So the charges are greater. So we have to make a final conclusion. Interestingly, the lattice energies are given in the next part. It means it's a subtle effect. Otherwise, he won't be giving us the values. Look at the part number 3. Examiner has given the values.
Yeah, of sodium chloride and radium sulfide.
Sodium chloride is -771.
Yeah.
And the rhodium sulfide is -2612. Okay, so it means there are two factors. So first we talk about charges. The product of the charges for radium sulfide is more than NaCl.
Yes.
So first you write this point that the the product of charges, ionic product, charge product is more for radium sulfide.
Okay.
So now can you tell me from the periodic table that S minus 2 and Cl minus 1, are they in the same period?
Yes, they are. They are in the same period.
So sulfur minus 2, sodium plus 1, and radium plus 2. Which is bigger?
Radium.
Radium. And what about the sulfur?
The sulfur will be bigger.
Okay. So I will write in a shorter form here, Q plus Q minus is more for Ra plus 2, S minus 2. So delta H lattice of RAS is more the charges product favors the product of charges favor that RAS should be more exothermic. Now ionic separation R plus R minus, it is inversely proportional.
For ionic separation, NaCl will be favored.
Right. So I will say that R plus R minus favors NaCl to be more exo because it's inversely proportional.
Yes.
This is called subtle effect. One is favoring RAS, one is favoring NaCl. But now look at the data in the part 3, which decides that radium sulfide is more exo than sodium chloride. So now what do you think, which is the dominant factor?
The charge.
The charges, the product of the charges.
Yes.
The answer would be product of charges. So we did one question. It's a good revision, and obviously it takes time. In the start, when you start a chapter, after doing 5-6 questions, then things get normal. We are starting our second chapter. The name of the chapter is electrochemistry.